Hello everyone. In this lecture we are going to discuss change the order of integration. So I am going to explain this using one example, and the example is change the order of integration and evaluate the double integral from 0 to 2 and 2 minus square root of 4 minus y square to 2 plus 4 minus y square dx into dy. First of all, we are writing this given double integral in details. So for this we can observe the limit of this inside integral are the function of y. That means for this integral our x is varying in terms of y. So that we can write this inside integral as x equals to 2 minus square root of 4 minus y square to x equals to 2 plus 4 minus y square. And we can observe this outside integral is moving constantly. So for this integral our remaining variable y will be varying. So we can write this outside integral as y equals to 0 to y equals to 2, and here f of xy is 1, so I am writing here 1. Obviously if x is varying for this inside integral, then we have to take an integration with respect to x, and if y is varying, then that times we have to take an integration with respect to y. Now after that we have to decide our region of integration using that limits of the integration. So the region of integration is bounded by x equals to 2 minus square root of 4 minus y square, that is nothing but lower limit of inside integral, x equals to 2 plus square root of 4 minus y square, that is upper limit of inside integral, y equals to 0 and y equals to 2, that is lower limit and upper limit of outside integral. So these all curves makes a region of integration. Now we are writing this given curves in the standard form. That means if I take these 2 to LHS side, then I will get x minus 2 equals to minus square root of 4 minus y square. And after that if I take a squaring to both side, we will get x minus 2 bracket square equals to 4 minus y square. And after taking this minus y square to LHS side, it will get x minus 2 bracket square plus y square equals to 4. And we know that this is the standard form of circle, having center is 2, 0 and radius is 2. Similar way we can write this second curve as a x minus 2 equals to square root of 4 minus y square. Again if I take a square to the both side, we'll get x minus 2 bracket square, and if I take this minus y square to LHS side, we'll get x minus 2y square plus y square equals to 4. So these both equations are the same equation of circle having center is 2, 0 and radius is 4. And this y equals to 0, that means our whole x-axis. This y equals to 2, that is straight line which is parallel to x-axis. Now first of all we are plotting all these curves on the graph, and if I plot these curves on the graph, then this will be the figure. So in that, this circle is nothing but this standard circle, that is x minus 2 bracket square plus y square equals to 4. So this is the center of the circle, that is 2, 0 and having radius is 2. And this third line, that is y equals to 0, that is nothing but whole x-axis, and y equals to 2, that is nothing but straight line which is parallel to x-axis. So this line is a y equals to 2, and this line intersecting at the point 2, 2 to the circle. Now we can observe this shaded region. That shaded region I have find out, or I have decided using this limit of the integration, and this open strip shows that our order of integration, that is this shaded strip shows that the lower bound of our region of integration is starting from this curve and ending at this curve. So equation of this curve is nothing but our lower bound, that is x equals to 2 minus square root of 4 minus y square, and equation of this curve, that is upper bound for this region, is x equals to 2 plus square root of 4 minus y square. So according to that limit we have decided this region of integration. And similarly the boundary for y is nothing but y equals to 0 to y equals to 2, that means this y equals to 0 to this y equals to 2. So that shaded region shows that our region of integration, and this strip shows that our given order of integration. Now our next target is to find change the order of integration. That means now we have to find the limit according to the vertical strip. So for this I have drawn again one figure. In that our target is to find region of integration using the vertical strip which is parallel to y-axis. Here I have drawn this vertical strip randomly. You can take anywhere, but just this strip should be parallel to y-axis. So now we are finding the limits using that vertical strip. So we can observe this vertical strip is touching at this line, that is y equals to 0, at lower side, and the same strip is touching at this curve, that is equation of circle, at upper side. That means limits of y is from y equals to 0 to y equals to this equation of circle. Therefore if I rearrange this equation of circle for y, then it will be y equals to square root of 4 minus x minus 2 bracket square. So that is the variation of y. Y varies from y equals to 0 to y equals to square root of 4 minus bracket of x minus 2 bracket square. Remember one thing, whatever we are doing anything in the figure, then we have to mention it theoretically also. That I mention here, we consider the vertical strip AB which is parallel to the y-axis, that I did here, and we are finding the limits using that strip, so along this strip AB, and therefore I am finding the limit of this y, that is y varies from y equals to 0 to y equals to square root of 4 minus x minus 2 bracket square. Now after that we are finding the limits for x. Now we have to find the limit of x in constant. So this region is starting from this origin at left side and ending at this point, that is 4 0 at right hand side. So our limit of x is starting from x equals to 0 and ending at x equals to 4, and that is our limit for x. So that I mention here, x varies from x equals to 0 to x equals to 4. Now using that strip and figure, we got the limit of y and x. Now we have to evaluate this integral also. So using that variations of y and x, we are finding the double integral. Therefore using that limits, we can write our given double integral as the integration from x equals to 0 to x equals to 4, and the integration from y equals to 0 to y equals to square root of 4 minus x minus 2 bracket square into 1 dy into dx. Now here for this inside integral our y is varying, that is why we are taking integration firstly with respect to y, and after completing this integration we have to take a integration with respect to x. Now we are finding integration with respect to y. So integration of 1 with respect to y is nothing but single y, and the upper limit, that is y equals to square root of 4 minus x minus 2 bracket square, and lower limit y equals to 0 as it is. Now in the next step we are putting upper limit and lower limit. So if I put upper limit instead of y, then it will get as it is term, that is 4 minus bracket of x minus 2 bracket square, minus if I put lower limit then it will be 0. So I have not written this. So this is the upper limit minus lower limit value. Now we can observe these terms contain only x variable. There is no y in that function, that is this is only function of x. That means our integration with respect to y is totally completed. Now we have to take an integration of this term with respect to x, and we know that the integration of a square minus x square formula. So we have to use that formula, but we are making the formula for this square root, so that the integration of square root of a square minus x minus b bracket square dx equals to x minus b upon a square root of a square minus x minus b bracket square plus a square upon b sine inverse of x minus b upon a. So this is the formula of this. So using that formula, the value of or integration value of this is nothing but x minus 2. X minus 2, that is this x minus b upon 2, that is nothing but value of a, because here 4, that is a square, so a is 2, and square root of 4 minus x minus 2 bracket square, that is as it is, plus 4 upon 2, that is nothing but a square upon b, so this is 4 upon 2 into sine inverse x minus b upon a, that is x minus 2 upon 2, and the upper limit, that is x equals to 4 and x equals to 0, that is lower limit. So in the next step, now we are putting upper limit and lower limit. So if I put upper limit, that is x equals to 4, then I will get 4 minus 2, that is instead of x I am putting 4 now, so 4 minus 2 upon 2, square root of 4 minus, instead of x we are putting 4, so 4 minus 2 bracket square plus 4 upon 2 as it is, sine inverse of x minus 2, that is 4 minus 2 upon 2. So this is upper limit minus, now if I put lower limit, that is x equals to 0, then everywhere x equals to 0, so this will be 0 minus 2 upon 2 square root of 4 minus 0 minus 2 bracket square plus 4 upon 2 as it is, into sine inverse of 0 minus 2 upon 2. Now after simplifying this, I will get first term 0 because of 4 minus this 4 minus 2, that is 2 square, that is 4, so 4 minus 4, that is 0, so due to this square root, whole terms will be 0, and therefore this will be 0 plus 4 upon 2, that is 2, value of sine inverse of 4 minus 2, that is 2, 2 upon 2, that is 1, so sine inverse 1 value is nothing but pi by 2, minus the second bracket, again here because of this square root, value of this first term is 0, plus 4 upon 2, that is 2 as it is, into sine inverse of 0 minus 2 upon 2, that is sine inverse of minus 1, and the sine inverse of minus 1 value is minus pi by 2. So this is the upper limit minus lower limit. So if I calculate this, I will get pi plus pi, and pi plus pi is 2 pi. So that is our final answer. Thank you so much.